Hi Year 7, welcome back to length. This is our sixth and final lesson on length. We're going to look at perimeter involving parts of a circle. That's the plan. Sound good? Let's give it a go. So here we are, we've got our two lovely little formulas again. This one, I might do green, it shows up better. Our green formula, C equals pi times diameter, which we use for diameters. And our other formula over here, C equals 2 pi r, which we use when we have a radius. When we calculate the perimeter of shapes involving parts of a circle, we can't forget the straight edges, double exclamation mark. So let's see what that looks like. Examples. Find the perimeter of each shape. 2, 1, dp, to one decimal place. Here's a lovely little shape. You might want to pause the video while you give that a little draw. I'm going to go for a little bit of a color code. I'm going to do the curvy part in blue, and the straight line can be in red. So the first thing to work out is what is the total perimeter. I'm going to use P for that. I'm going to say perimeter is equal to the part in blue plus the part in red. That's the plan. Now the part in blue, that's like a whole circle circumference, but it's only a fraction of it. What fraction of a whole circle is this? It's a half, so I have half of the circumference. So I have 1/2 of. Now 1/2 of is the same in maths as 1/2 times. Of means times. Of means times. I might even green that one. Maybe you want to just write down of means times. I'm not sure if you've heard that one before, but I'm telling you now. Of means times. So half of means half times. So 1/2 times. And then we ask ourselves, what is the circumference of the whole circle? Well, I've got the diameter, so I'll use pi times diameter. Half times pi times diameter. There we go. Pi times diameter will be the whole circle. Half times that will be half of the whole circle. To that, I add the straight line, which has length of 28, and I'll get my answer. Picking up my calculator, I'm typing 1/2. It's doing 1/2. When I do fractions on my calculator, I might have to press one of my 4 arrow keys that are at the top to get my cursor from there up to here so I can do a times. Half times, press the shift key to get pi, times 28, plus 28, into my calculator, and I know to write down lots of digits. 4 is probably enough. 71.9822, it goes on forever. We're going to round to one decimal place because that's what we've been told to do. So let's do that. Oh, hold on. I've got to show where I'm chopping it off. Chopping it off there. Okay. So, because the 9 goes up, it'll go up to a 1, 0, which means I have to add 1 to this column, and this one will still be 0. So 72.0, the units are centimeters. Do I need to have the 0.0 is a good question. This is just 72. Do I need to say 0.0? The answer is yes. Because it says to one decimal place, I need to actually show that decimal place. And that's it. That's the question. So we have to show our working out, or rather what we typed into our calculator, what the calculator said, and then what our answer was after we rounded it. All right, let's go do some more. That was me high-fiving myself there because, you know, who else is going to? And you need to be high-fived, so you might have to high-five yourself. 2 more. 2, 1, D, P. Here's my picture. What shape is that? You've seen it before when we did parts of a circle. Oh, too good. Yeah, it's a quadrant. It's a quadrant. Well done. Well done. Well done. Okay, so our perimeter is this bit plus this bit plus this bit. Easy peasy. What's our curly bit? Well, it's a quadrant. Clues in the name. It's a quarter of a circle. What is the perimeter of a circle? It's the circumference. Which formula am I going to use? Is this a radius or a diameter? It's a radius. 2 times pi times r. Twinkle, twinkle, little star. Circumference equals 2 pi r. And I'm just going to put the number straight in. The number is 16. All right, that's the blue bit. We need to add the red bit and the green bit, and we're done. Red bit and the green bit. If this is 16 and it's a radius, this here is actually also 16. Why is it 16? Because radii, that's the plural of radius, are equal in length. So if this is 16, this has to be 16. Plus, actually I might go change my color a little bit. If it would behave. There we go. Plus the green bit. All right, straight into the calculator. ... Approximately equal, and then we'll be done. Okay, 1/4 times. You don't actually need the brackets because it's all times. 2 times pi. 1/4 times 2 times pi times 16 plus 16 plus 16. Ooh, this looks like a nice number. I've got 57.1327. It keeps going, so I put a ... One decimal place. That's where we cut it off. 57.1 or 0.2. It's a 3, so it goes down. So it goes down to 0.1. We just chop this part off. It gets chopped off, it stays where it is. And the units, millimeters, done. Easy. Maybe not easy, but we got there. We got there with a nice bit of color. All right, question C. Let's give C a go. This one says exact value, which means we might need some of our algebra skills again. That's okay. We'll review the parts that we need. Okay. So before we start, I'm going to draw some things in our picture. Some things that aren't here, but we kind of know. This is a little right angle in here, which makes this a rectangle. So if this is 10, that's also 10. And if this is 34, this is also 34. And then I think we're good to go. Let's go have our curly part. That's probably the hardest part of this shape. Then we've got a red bit, maybe another red bit, and a green bit. Need to add all of them up to get our answer. Okay. Our perimeter is the curly bit, which is a half of, so half times, of means times, and then the circumference of a circle. I need to decide, is this a radius or a diameter? Does it go halfway across or the whole way across? It goes the whole way, it's a diameter. So I will be using C is pi times D. Pi times 34. All right. Plus 10, plus 10, plus 34. There we go. That's our formula. Now it says exact value, so I probably won't need a calculator for this. I probably won't. Let's start with this part. So there's an idea in algebra about what a term is. And a term is things that are separated by plus and minus signs. So in this part, I've got 1 term, 2 terms, 3 terms, 4 terms. I'm just going to look at this part here, okay? Just treat it by itself. Forget about the rest of this. Just looking at this part here. How can I make this a bit simpler? I've got a half times pi times 34. What I can do is reorder the multiplication. I can put the 34 before the pi, then I've got a half times 34. And I know what a half times 34 is. It's 17. Okay, Our letters go at the end, and we don't write time signs. It's 17 times pi. So this part here in purple is now 17 times pi. I'm going to get rid of these underlinings, and maybe I'll use a different color. What's a fun color we haven't used? Ooh, pink's fun. I like pink. Let's go do pink. Bright pink. Okay. So our purple bit went there. All right, now 10 plus 10 plus 34. I know you know what that is. That's 54. So I can add these three terms together and get 54. That's where my pink terms have gone. Okay, now I've got 17 times pi plus 54. There is actually no way to combine these. This one has a letter and this one doesn't have a letter. They need to have exactly the same letters to combine them. So it stays as it is. It stays with a plus sign. That's my final answer. I just need to write the units, meters, and we're done. That's the end of that question. So we used a lot of brain power, but it didn't take up much space on our page. All right, well done. Let's keep going. All right, let's go have a look at this one. Do we want to do exact value, or do we want to do, what's the other word? To one decimal place. It doesn't say, so it's going to be our choice. Now, normally I would choose exact value every time, but we're in year 7 and we're still learning. So let's do the one that's more likely to be useful to you, which would be one decimal place. Okay, so 2, 1, dp, 2, 1, dp. Same strategy, curly putt, straight putt, straight putt. Perimeter is the curly putt plus the straight putt. Now I need to know what fraction of a circle I've got here. I've got a little arc. It's called an arc. What fraction of the circle is my arc? So how many degrees are there normally in the center of a circle? It's not 60, it's 360. I've got 60 parts of that 360. So I could say that is 60 360ths of my circle. 60 360ths of the circumference. However, maybe you know a lot about fractions and you know that that's actually 1/6. Up to you. You can write 60 over 360 or you can write 1/6. All right, do I have a radius or a diameter? I've got a radius. So 2 pi r. 2 pi r, which is 18. Plus the straight part, plus the other straight part. We've got a problem for your calculator. Type it in, get your answer. Let's give it a go. So don't forget, when you're doing fractions, you might need to press an arrow key to bring your cursor from the bottom back up to the middle so you can write this time sign. 60 over 360 times 2 times pi times 18 plus 18 plus 18. Beep, beep, beep on my calculator, and I get 54.849555592. I get a lot of digits. I think we decided one decimal place. That's where we chop it off. Look at this digit. It's a 4, so chop it all off. It doesn't round up. It stays as it is. 54.8 centimeters is our final answer. Very exciting. This was our penultimate question. Penultimate is a really fancy word that means second to last, with ultimate being the last. This is our ultimate question, our last question. Now that's actually a small lie. I'm going to do a couple of other questions after this, but this is the main last question for a while. All right. This question is actually the same. There's barely any difference between this one and the last one. We've got a curly part, a straight part, and a straight part. So I need to know what fraction of the whole circle I have here in blue. Well, I know that the whole way around, the whole angle would be 360, but I'm missing this part. I'm missing 120. 360 take away 120, beep, 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 is 240. So my angle that I have is actually 240 degrees. And that tells me the fraction that I have. I have 240 of the total 360 parts of, which means times, the circumference. And I know what the circumference is. It's 2 times pi times r. Goodness, we're putting it all together really fast, aren't we? Now, some of you might know this fraction here. It's actually just 2 over 3. It's just 2/3. If you wanted to replace that with 2/3, that's fine. But I'm going to put this in a calculator anyway, so it doesn't bother me, because it's not in my final answer. Plus 5, plus 5, plus 5, plus 5, and we're good to go. All right, calculator time. 240 over 360 times 2 times pi times 5 plus 5 plus 5. Now, I was actually a bit sneaky. When I went to type that into my calculator, because the calculations are practically the same, all I did was change this to that and change the 18s to 5s in my calculator. I just kept the same expression up there. Because I was fast enough, it hadn't disappeared. So I saved some time typing it in, because most of it was there. 30.9439 ... Time to round. It's funny because we're doing rounding when we're doing circles, because circles are round. No? No. No one laughed at that. Okay, that's fine. What do we get? We get 30.9 meters, because this rounds down. This part here gets chopped off, doesn't affect it. 30.9 meters. Fantastic. Okay, now I'm not sure what work's going to be set, so make sure that you read the post about what your class is doing. I don't know that we have these with us where we are, so it might be some work from the textbook. I'm not sure. I'm going to flick through the next pages and show you what there is, and then I'm going to do an extension question. So well done for getting this far. We're at the end of the unit. How exciting is that? So good. Well done, everyone. So I've got lots of sheets here. I'm not exactly too sure what's going to be set. I'm not sure which ones that we have, but there's a lot of work, so hopefully there'll be some nice work for you to do. So if you're hanging around now, you're here because you want to write down all of the things that we learned in length. What did we learn? We learnt converting units. I think we did that in our first thing. What did we learn? We had our little table where we had our 1 kilometer. Did we have 1 kilometer? No, we just had kilometer. Kilometer, and then if you multiply by 1,000, you get down to meter. And if you multiply by 100, you get to centimeter. And if you multiply by 10, you get to millimeter. And it went the other way as well. I've seen students in year 12 walk into an exam and they'll write this down to remind them how to convert. That's one of the things that we did. Oh, that's a bad line, isn't it? What else did we do? We did parts of a circle. When we did parts of a circle, we had things like a radius. We had a diameter. We had a sector. We had a segment. we had a chord, we had a tangent, did we do secant? I'm not sure if we did, but that's a secant there. I don't think we did secant. It's a bit of a silly one. And, oh, we had things like semicircle as well. It's a funny semicircle. Yeah, we had lots of good parts of circles. All right. Another fun thing we had pi. Pi. 3.1415926535897. That's all I remember. Maybe you know a bit more. We had that. That was lots of fun, wasn't it? Lots and lots of fun. If you want a way to calculate pi because you're really bored on a desert island, here's one that I remember. This is from the Bernoullis. I believe it was Jacob Bernoulli, but it might be pronounced Jacob Bernoulli. And he came up with pi is equal to, and this is exactly equal to, and what you need to do is you need to go 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus literally every single number forever up to infinity. You need to do all of that. Then you need to multiply that whole thing by 6. And then you need to take the square root of that whole thing. So that's kind of fun if you're just sitting down. You go 1 plus a quarter plus a ninth plus a 16th plus a 25th plus a 36th plus a 49th plus a 64th plus an 81th plus a 100th, and you can keep going. And if you get all the way up to 20, you might get sort of like 4 decimal places. So that's a fun way to calculate pi. What else did we do? The big thing that we did, which is why we had to go look at pi, was we did perimeter, which was the length as you go around something. And we did perimeter of squares. We did perimeter of rectangles. Perfect drawings there. This one was 4 times S. This one was 2 times L plus 2 times W. And then we looked at circles. And when we looked at circles, sorry, I should mark what S and W and L are. When we looked at circles, we had 2 separate formula for their perimeter, which we called a circumference. Instead of going P for perimeter, we went C. And we went, the circumference is 2 pi r because of twinkle, twinkle, little star. Or we said it's pi times diameter. If you're wondering where that comes from our definition of pi. We said pi is the circumference divided by the diameter. So if we change that into a multiplication, we get the circumference is d times pi. The circumference is d times pi. And then replacing d with 2r, we get c as 2 pi r. So there we go. Those are our ideas that we got. Our ideas about perimeter and length. Did a lot of stuff in this unit. So if you want to do a nice little summary page, that's up to you. There's also chapter reviews to do as well. Well done, Year 7. Good job. I better go start preparing the next topic. Very fun.